In mathematics, frequency tables and averages are essential tools for summarizing and interpreting data, providing clarity about patterns and typical values within a dataset. Frequency tables help to organize data by showing how often each value or group of values appears, making it easier to analyze large datasets at a glance. Averages, which include the mean, median, and mode, further refine our understanding by indicating central values or typical outcomes in a dataset. A frequency table is a structured way of displaying data, listing each unique value or category alongside its frequency or the number of times it occurs. For example, if we survey a group of students on the number of books they read in a month, we could list each possible response in a frequency table with the corresponding frequency of each answer. This makes it easy to see which values are most and least common, and to identify patterns, such as whether most students read a similar number of books. The table can include additional columns for cumulative frequency, which shows a running total of frequencies as we move through the data. Cumulative frequency is particularly helpful for determining percentiles, identifying how many values fall below a certain point, and visualizing data distribution trends. Grouped frequency tables are quite useful when dealing with continuous data or larger data sets, where individual values may be less relevant than ranges. For example, in a data set of exam scores, rather than listing every possible score, we might create ranges or intervals, e.g. 0-10, 11-20, and so on, and record the frequency of scores within each interval. This approach simplifies the data, allowing us to see the overall distribution without being overwhelmed by too many details. Grouped frequency tables are especially useful when we need to estimate averages or when a visual representation, such as a frequency bar chart, is based on grouped data. Averages provide a summary of a dataset by describing a central or typical value, and each type of average has unique properties suited to different contexts. The mean, often referred to as the average, is calculated by adding up all values in the dataset and dividing by the number of values. It provides a good representation of data when values are relatively close together, but it can be skewed by extreme values or outliers. In a set of incomes, for instance, one very high income can raise the mean significantly, giving a misleading impression of the typical income. In cases where outliers are present, other measures of central tendency, such as the median, may be more appropriate. The median is the middle value in a dataset when the values are arranged in ascending or descending order. For datasets with an odd number of values, the median is simply the central value. For datasets with an even number of values, it is the average of the two central values. Unlike the mean, the median is unaffected by extreme values, making it a reliable indicator of central tendency when outliers could distort the results. For example, in a set of house prices, where a few properties might be exceptionally expensive, the median would give a clearer sense of the typical price without being pulled upwards by these high values. The mode, another measure of average, is the most frequently occurring value in a dataset. This measure is particularly useful for identifying the most common value, especially in categorical data. For instance, if we record the colors chosen by a group of people, the mode would simply be the color that appears most frequently, providing insight into preferences within the group. In some cases, a dataset may have more than one mode, which occurs when two or more values have the highest frequency, making it bimodal or multimodal. In other cases, there may be no mode at all if each value appears only once. To calculate the mean, median, or mode from a frequency table, we adapt these definitions to take frequency into account. For the mean, we multiply each value by its frequency to obtain the total for that value, then add these results and divide by the total frequency, which is the sum of all frequencies. This weighted approach ensures that we accurately represent each value's contribution to the overall average. To find the median, we identify the value that falls at the midpoint of the dataset when all values are accounted for by frequency. This can be done by finding the cumulative frequency and identifying where the middle frequency lies. For the mode, we simply look for the value with the highest frequency in the table, as this represents the most common outcome. In the case of grouped frequency tables, where data is organized into intervals, the median and mode can be estimated, but the exact values may be more approximate. For the mean, we use the midpoint of each interval as a representative value, multiplying it by the frequency to calculate a total, then dividing by the total frequency. This provides an estimated mean based on the assumption that values are evenly distributed within each interval. To estimate the median, we use cumulative frequency to find the interval where the midpoint lies, and for the mode, we identify the interval with the highest frequency, known as the modal class. Understanding frequency tables and averages allows us to summarize large amounts of data effectively, enabling clearer insights and comparisons. While each measure has its strengths, knowing which one to use in different contexts is essential. By combining these tools, we can both simplify and analyze complex data sets, providing valuable perspectives on the data's distribution, trends, and central values.